Hello and welcome to the Microbehunter Microscopy Podcast. My name is Oliver Kim. So let's talk about different microscope standards today. The most common standard is the so-called 160mm DIN standard, and however there are also other standards as well, like for example the less common 170mm standard. And they're so-called infinity optics, and they are not standardized over different manufacturers, but different manufacturers simply define their own standards, so these are proprietary. Let me explain what these things first mean, and then later on I'd like to talk a little bit about how this is relevant or not so relevant for amateur microscopists. Basically, it's like this. Every microscope has an objective and an eyepiece. And the 160mm standard, the 160mm refers to the distance between the specimen and the point where the objective generates or makes an image. It is like this, that the objective projects an image into the tube of the microscope, which is then further magnified. So 160mm refers to the point inside the microscope's tube where this image is made. And this image is then further magnified by the eyepiece. The 160mm standard has been around quite a long time, and this means that every microscope that has this standard, you can exchange the objectives. It is also the threading is standardized. So it's a so-called an RMS threading from the Royal Microscopical Society. They've once defined this, and you can essentially exchange the objectives. Having said that, if you exchange the objectives, they all have to be from the same series. It is quite well possible that if you attach a new objective to the microscope, even though it does fit, this image might be out of focus compared to the other objectives. So this is something that you might want to consider. For example, I've exchanged one of my objectives, the 100x oil immersion objectives, with a very low cost, no name 60x objective, and of course, it fits into the microscope, but when I change the magnification, I have to refocus a little bit. It's because the objectives are not parfocal. Parfocality refers to the fact that you do not have to refocus the microscope, but it fits. Okay, so that's fine. In recent years, what microscope manufacturers have come up with is so-called the infinity optics, and they are quite. They're totally not compatible at all. Yeah? First of all, the threading might not fit because it's manufacturer specific, and also the way that the optics work, it also doesn't work. I've heard that some people have managed somehow to attach an infinity objective to a classic 160mm microscope, and they were able to get it to work with a lower image quality, but that is not something that you normally would do. Okay, so that is, I would say, rather experimental. So how do infinity optics now work? Well, first of all, some of the things that have to be common. You still need an image inside the microscope's tube to be magnified. That is the bottom line. To be magnified by the eyepiece, that is. Okay, so that's the bottom line. But the way that this intermediate image is generated is somewhat different in infinity objectives. So how does this work? It is like this, that the objective of this microscope generates a light beam which is not focused to a point, but where the light beams are parallel. And then only inside the microscope's tube, so much later, there is an intermediate lens which then generates, which bundles the light to then generate the real intermediate image. You have a relatively large distance between the objective and this intermediate lens where the light rays are parallel. Now this has a significant advantage because you can now insert a variety of filters into this parallel light beam, and this does not have any effect on the focus or on the magnification of the objective. Because the light rays are parallel, and if you put in a filter, then the light rays will stay parallel. If, on the other hand, if you have insert a filter into the light beam of a 160mm objective, where the light beam is already converging, if you insert a filter in a converging light beam, then this kind of has an effect. Okay, So the infinity objectives allow you a little bit more flexibility in inserting filters and having special types of intermediate optical elements without changing the picture of the microscope so much. So that is the technical advantage. The fact that the light rays are parallel before they are passed through the tube lens, that is, has another advantage for some applications, namely that you can now build the microscope pretty much any size that you want. And this allows the manufacturers also to build microscopes of a larger size. With a 160mm objective, you had to take this focal point of the 160mm into consideration. And now with the infinity optics, it is possible to extend the tube as much as you want. And then you just add the tube lens, and this focuses the light rays down back to a point. And so you're much more flexible concerning the size of the microscope. When I back in the year 1998, before I bought my microscope, I talked to several representatives of several microscope manufacturers, and this was the time when the infinity optical systems, they started to be introduced. And I asked the representatives of Nikon and Olympus. I just happened to have them at they were just happened to be there at the Congress that I visited. So I talked to those representatives, and they independently of each other gave very similar opinions. I asked them, what do you think about the infinity objective systems? And they both essentially said, well, yeah, it's almost a question of taste. It's nice to have, but it's not really necessary, and we'll see whether this system is going to be successful in the future. This was kind of the thing that they communicated to me as a consumer. So actually one of them actually said, yeah, it's kind of a question of taste. Interesting. Right now, if you look at the four big microscope manufacturers like Olympus, Zeiss, Nikon, and Leica, they all switched over to infinity optics. Maybe I know that Leica, this company, has also educational microscopes still in the series, which are still based on the older 160mm standard. But generally they all moved over to infinity optics. And this means that you cannot exchange your objectives between these microscopes anymore. Yeah? It's, I think one of the reasons is not only the technical advantage of being able to insert filters, but I think this was also a way for the different companies to somehow, how shall I put this, push their own system a little bit. Okay, if you want to say it in a negative way, you're kind of dependent on the microscope manufacturers if you want to upgrade your microscope. In the past, with a 160mm system, you just went to any no-name manufacturer and you basically got yourself an objective, and it worked. That's not possible with the infinity optics anymore because it's proprietary to the manufacturer, and every manufacturer defines its own standard. So what does this all mean now for the amateur? If you want to get a microscope from one of the four big microscope manufacturers, Olympus, Nikon, Zeiss or Leica, then essentially you are almost bound to go for infinity systems. These manufacturers have switched over. And they're now producing infinity systems. Some of these manufacturers, as I already mentioned, Leica is the only one that I know of right now. They have a few microscopes also using the 160mm standards because they have got an educational branch as well. And for those lower cost microscopes, they still use the 160mm DIN standard. For all of the other microscopes, you are now bound to go for the infinity system. Check out their web pages and you're probably going to realize that the high cost of many of these microscopes essentially already answer for itself. I mean, if you have to pay several thousand for a microscope, then this is often beyond the budget of an amateur. So that is often, so therefore, in other words, the decision infinity or non-infinity often does not even appear because it's already decided simply by the price of these infinity microscopes. Having said that, simply because a microscope has a 160mm system does not automatically mean that the image quality is any worse. Modern 160 millimeter objectives are of course manufactured, and they are used very widely in the educational and in the amateur sector. So these are not outdated objectives. It is, I think, what has happened in the last, I don't know, 20 years or so is that the big microscope manufacturers, the brand name manufacturers, what they tried to separate themselves a little bit from the other manufacturers, the no-name manufacturers and smaller manufacturers of microscopes. So they've gone their own way. They have pushed their own infinity standard, and they kind of left the lower cost microscopes to the 160 millimeter DIN standard manufacturers. So I think this is something that has happened a little bit. Why this is, I guess it's some kind of a strategy, some kind of a management decision here. But what I would like to say is that the reason is it's not necessarily that the infinity optics automatically give you a better image quality. Having said that, what I heard is that they indeed do have a very good image quality, but this is not necessarily due to the fact that they are infinity optics, but rather because they're using very modern manufacturing techniques and very modern glass chemistry and all of these things. So simply because they are simply more modern and they're now computer calculated and so on, which was not always done in the past, this is the reason why some of these objectives have a very high quality. But this is not an inherent issue concerning infinity optics. Now, there are also some smaller microscope manufacturers that have infinity, an infinity program. The question is, should you go for that? And here I have mixed feelings. Because these are smaller manufacturers, it is more difficult to obtain second-hand and lower cost objectives this way. So what I've heard is also in some web forums this was discussed. People had an infinity system from a smaller manufacturer and had real problems getting spare parts because there were simply not that many around, and because it was its own standard, it was also not interchangeable with other microscopes. So if you decide to go for an infinity system, if you have the budget, then do go for the large microscope manufacturers, okay? Because they are, they are selling to universities and research institutes and all these. Their target group is different, and therefore they also have a larger stock they have a larger stock of objectives available. Okay, so that is simply a short recommendation that I can make here. So ultimately that's pretty much it. That's all I wanted to say. Your last thing maybe, how do you actually recognize an infinity microscope is there is an infinity sign on the microscope objective. Okay, and this is a sign that you have, and if if the number 160 is written on it, then this means that it is the 160 millimeter DIN standard, the DIN standard. Okay, so that is pretty much it. I hope that I was able to clarify some of the issues here. And wish you a nice day and all the best.